Just double checking. Okay, cool. Um, it's a pleasure to be here. I'm Hossein Shokri from KTH Royal Institute of Technology. I'm postdoctoral there. And today I'm going to present some of our findings in Match IT. I'm not an expert in energy systems, so I should say that, but I'm expert in machine learning, IoT, essentially in how to deal with data and how to do some math on the data to extract some information about that. And when we are talking about energy systems, we know that there are lots of data. Either there are lots of data or there are going to be lots of data. So we do have this problem. And that was a project jointly with these four organizations, KTH, VATI, and Metri. And these two companies were responsible for providing either data set or some problems that they do have in their applications. So what was our findings or our contribution in general to this project? Essentially, there are two different class of problems that we observe that we would have in energy systems. So first of all, imagine that we do have a very massive energy system, distribution energy systems. Then we do have two different kind of problems. First of all, there are going to be a lot of sensors there, and you need to collect all those informations, and those data could be heterogeneous. But this is just one kind of problem. So how you can collect those data and how you can process those data. So this is one problem. The other problem is that in many cases, you do need to deal with cheap sensors simply because you need to have a massive amount of those sensors. And since those sensors usually are cheap, then what happens is that the quality of data that you will get from them is really poor. So what does it mean? It means that you do have a lot of missing values, and you have no idea what to do with them. In many cases, the data and the different classes are imbalanced. So for example, that was the case with Metri dataset. So they were collecting data from residential buildings, from utility consumptions, and for their water sensors, they did have a lot of good quality sensors and good quality of data, but for the electricity, they didn't have, simply because some of the sensors was off during, I don't know, something like 2 months or 3 months period. So you can imagine that you want to do some form of machine learning data analysis on top of those data, but you don't have any data anyway. So how you can do that? So these are two branches. The first one is time series classification for smart grids, essentially how you can deal with those problems, as I said. So how you can do the classification task, do your data analysis on top of data sets where you do have missing values and you do have data class imbalance. And the other one is model compression for edge computing. So essentially, once you do have a lot of sensors, then the problem is that you don't want to put all those all those data in some centralized cloud and then process everything there, because it's just a massive amount of data. So can you do something locally and then reduce the load overhead on the communication part and computation part? And this is the other part. I would be happy to discuss more if you have any question.